Hi everyone, welcome back to Geeks for Geeks. In this video, we will discuss the problem maximum occurred integer. So let us read the problem statement and understand what we have to do in this problem. Problem says that we'll be given a integer n, and this integer n is indicating some kind of ranges. So task is to find maximum occurrence of integer in these ranges. So if more than one such integer exists, then we have to return the smallest one. So basically you will be given n ranges. Okay, if the n value is 3, this means that you will be given 3 ranges. So the ranges are given in two array. First is the L array and second is the R array. So L of I indicates the starting point of the range and R of I indicates the end point of the range. So what we have to do is we have to find we have to consider this example. So let's say L is given as what, 2, 1, 3 and R array is given as 5, 3, 9. So basically the first range will be from 2 to 5, second range will be from 1 to 3 and the third range would be from 3 to 9. Okay, so in this particular range you can see that the maximum occurred integer is what? From 2 to 5, 3 is occurring, from 1 to 3 also 3 is occurring, and from 3 to 9, 3 is occurring. So the maximum occurred integer in this particular case is nothing but 3. So we have to return the maximum occurred integer here. So you can observe that all the elements, if I am given a range, let's say I have been given a L of I and R of I. So let's assume that L of I is given as 2 and R of I is given as 5. That is the very first test case. So you can see here that L is given as 2, R is given as 5. So all the elements from 2 to 5 are occurring. So I need to count them, right? So one of the very basic and the brute force approaches will be that every time for every L and R pair, I can iterate for all the elements from L to R and I can increase their frequency, right? But if I will do this, so for one particular ith index, for one range, I will take order of n time to update, because if I have the range from 2 to 5, so every element for every element in the range L of I to R of I, I'll increase the frequency. So in the worst case, that would take order of n time, because I'll be iterating in the worst case through n elements. Okay, and if I'm doing for n times, let's say if I'm doing it for n times, so in that case it will be n square in nature. So basically this will be square in nature, and the time complexity is very high because it is square. So can I reduce the time complexity? Yes. If I want to reduce the time complexity, then what I can do is I can use the concept of prefix sum here. How I can use the concept of prefix sum? Because suppose that the elements are occurring in this fashion, and then let's say after that the next thing is that let's say you have L of I as what? Let's say you have L of I as, let's say, something like 3, okay, and then you have got R of I as what? Let's assume that R of I is nothing but 7. Okay, now if we do what? If we build an array, let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's say this is our array that we have from 0 to 9 indexes. Initially all the values will be 0. So let's mark all the values initially as 0. Okay, then what we can do is, like, see, normal, like, we always have to update the frequency, but if we do it in the traditional format, or if we do it in the straightforward fashion, brute force fashion, so that would be overall order of n square, because for one range from L to R, I'll take order of n time to update all the frequencies for every element in the range L to R, L of I to R of I, and for all the queries I will take n into n time, that's n square. So if I want to optimize it, what I can do is I can declare a prefix array. Initially everything will be 0, and then whenever I am at L of I can increase it by 1. So what will happen here is I'll increase this guy by 1, so this will become how much? This particular element will become 1 here, and then R of I plus 1, I can mark it as minus 1. So if this element is 5, I will mark 6 as minus 1. So at the element 6, I'll update it with minus 1. So I'll add minus 1 into that index. Okay. Now what will happen because of this? If you see later on, when I'll take the complete prefix sum, then what will happen? Later on when you will take the prefix sum, then this will be 0, this will be 0, this will be 1, this will be 1, this will be 1, this will be 1, and this will become how much? 0, 0, 0, 0. So basically by adding minus 1 to the next index, what you have done is you have made a covering layer that whenever you will be taking the prefix sum at the end, so that ranges increasing frequencies will not impact the indexes that are outside the range. For example, if you had the elements from 2 to 5, right? So you have to update all the elements from 2 to 5, you have to update the frequencies by 1 because of the range L to R. So you have marked the second index as plus 1, and I plus, like r of I plus 1 index as minus 1. Then what will happen when you take the prefix sum? So all the elements from index 2, 3, 4, 5, they have updated their values with plus 1, and at the index 6 you are having minus 1. So you will, when you will take the prefix sum, then at all these indexes the value will increase because you are taking prefix sum. So that is 1 getting carried forward through the next indexes, adding in the next indexes. But when it reaches 6, then you have to stop the effect. So that's why you have added a minus 1. So from here you will keep on adding 0. So that is going to be the impact. Okay, but we'll take the prefix sum at the end only. So now what will happen? Next time, suppose if we will do what? After this, next time at L of 3 we are going to mark plus 1. So let's quickly mark this. At L of 3 we are going to mark plus 1, and then in the array we are going to mark this as plus 1, and then r of I plus 1 as minus 1. So this is given as 7. So we will mark 8 as minus 1. So what we will do is we'll mark 8 as minus 1. Now we take the complete prefix sum. What do we get? So we get 0 here, we get 0 here, we get what? 1 here. Then we will get 2 here because 1 was already there and 1 more getting carried forward. So this is 2. Next time you have got 2 here, then 2 here again. Then you have got 1 here, then you have got what? 1 here, then you have got 0 here, 0 here. Right, so this is how the prefix array looks like. Now these are the indexes that you have, right? And the prefix array now looks like this in the black color. So if you will see what happens here is, now in this case you can observe that the elements were there from 2 to 5 first of all. Okay, then after that elements were from where to where? From 3 to 7. Okay, so basically from 3, 4, 5, you can see that 3, 4, 5 are the elements which are lying in both the ranges. Okay, so that is why the elements 3, 4, 5, they have their frequency as 2 in the prefix array, and rest of the elements are having frequency as 1. That is the element 2, 7 and 8, and 0, 1, 8 and 9 are not occurring in any range, so their frequency is 0. So what I have done is, every query, like if I have been given queries to update, so every query is taking order of 1 time to update. For updating one query, I'm taking order of 1 time. So for n queries, it would take n time only. And at the end, I'm taking a complete prefix sum to update all the frequencies finally. Because of this, what happens is, you can observe that I am taking order of n plus order of n time, that is linear time only, to update the frequencies properly without using the brute force approach. Now in this case, we'll iterate. So basically, if you will see here, the final answer will be what? For this particular range, you can say that my answer will be 3 because 3 is the element which has the highest frequency, that is nothing but 2, because the element 3 is occurring 2 times, 4 is also occurring 2 times, 5 is also occurring 2 times, but the smallest of them is 3. So that is why 3 will be my final answer, because 3 is the element with the maximum frequency, that is occurring 2 times, and the element is nothing but 3. So let's try and implement this in terms of code as well. So we are given the maximum limit of the array as well. Okay, so what we can do is we can declare a prefix array. So let's say we'll declare int prefix array, and then we'll declare it as max plus 1. Okay, let's say max plus 2. Okay, then after this, what we'll do here is we'll start iterating. So we'll say that int I starts from 0, I is lesser than, let's say, n. Then we'll do I plus plus. Okay, and then after that, in the prefix array, what we are going to do is we are going to update the prefix of L of I as plus plus. We are going to increase it, and then prefix of R of I plus 1, we are going to update it as minus 1. Okay, so why? Because at the Lth index, you will say that from the Lth index till the R, from L of I till R of I, you want to update all the elements with plus 1. But from the next element, that is from R of I plus 1 index, you want to neutralize that effect. That is why at the index R of I plus 1, you are updating the value as minus 1, so that there is a break there. So you'll keep on updating all the frequencies by 1 in the range L of I till R of I, and then from R of I plus 1, the effect will get neglected. Okay, so this is what will happen here. Now after that, we'll take a prefix. So let's say we'll initially declare our answer as 0. Initially, we'll assume that element 0 is the element that is having the maximum frequency, and initially we can update the maximum frequency, let's say, as 0. Okay, then after that, we'll iterate. So or we can update the maximum frequency as, let's say, prefix of 0 here, right? Because we are initially assuming our answer as 0. Now after that, we iterate from 1 till I is less than what? Till I is lesser than this max plus 2 size. Then we'll do I plus plus here. Okay, and after this, we'll do what? We'll say that prefix of I is equal to nothing but prefix of I plus what? Plus prefix of I minus 1. So whatever is there in the back side, we'll add it, right? So we'll carry forward the sum, and then after that, we'll check that if the prefix of I, if the frequency of this ith element, if it is greater than the maximum frequency, then I'll update the maximum frequency as prefix of I, and I'll update what? After that, I'll update the answer as nothing but I here. And then at the very end, I can simply return my answer here. So I hope that you have understood this particular approach. Let's try and quickly compile this to see if there is any mistake. Okay, it works fine on the samples. Let us now try and submit this code. Hopefully it should get accepted. Okay, so it is giving me a wrong answer. It says that my code's output is 6 and the actual output is 5. Okay, so I might have made any mistake somewhere. Let's check this. So initially what I've done is I have declared a prefix array, and yeah, I forgot to mark the initial frequencies as 0. So when I was declaring the array, I should have marked the frequencies as 0. So initially my prefix array will be 0 completely. Let's now try and run it. Yeah, you can see that now it's working fine, because if you don't initialize your array by default in C++, so it takes garbage values. So you can see that my code is getting accepted, and I hope that you're clear with the intuition and the logic of this particular problem. Talking about the time complexity of my code, so the time complexity would be nothing but order of n, because I am taking order of n time for updating all the ranges, for updating the prefix array, and then after that I'm taking another order of n time for what? For taking the prefix sum, right? So for updating all the frequencies finally. So this is overall order of n. Space complexity will also be order of n, because I'm taking a prefix array. So I hope that you have understood this question properly, and please comment understood if you have understood it completely. If you have any doubts, you can mention them in the comments. Thank you for watching this video.